Cool. It's going to be weird sitting down, so I'm going to be standing up and going down quite a bit. Don't be alarmed by this. Can you switch the? Yeah. So while this is happening, what are we going to do today? First of all, welcome to London C++ user group, because that's exactly what we're going to be writing. By a number of lines of code, Scala will be the least dominant language in today's presentation. So if any of you are familiar with Scala Native, what it is, just raise your hands. A couple. So in summary, Scala Native is a compiler plugin set of tools that allow to compile Scala code, any Scala code pretty much, without using reflection, compile it down to something called LLVM-IR. If you're not familiar with LLVM-IR, IR is a compiler, sort of compiler backend in a way that allows many languages, Rust, Scala, I think Swift as well. I don't think they directly compile. I think they compile to IR, to basically reuse some of the compiler infrastructure that has been developing over the last many decades, optimizations, various like loops, rolling and unrolling things. So Scala Native compiles to that level, and then LLVM tooling, Clang, the C compiler in Apple systems and others, they kind of do the rest. This allows you to build truly native binaries and native shared libraries, and really just go down to not bare metal, but like as low level as majority of the languages will allow you to do. So today, you know, when Jacob came to me and said, and it's almost a quote, he said, "Do you have anything to present in the 25-30 minutes between pizza and pub? And don't make it too long. The focus is going to be Nicholas' talk." I was like, that's a man that knows how to attract talent, how to pander to my ego. And he played it like a violin. And I was ready. I said, and I quote, "I'll do whatever." Like, so that's exactly what I did, basically. And then I actually forgot that I'm doing this today. So, and I spent the entire day covered in sawdust because of renovation. So I'm a bit fuzzy on the details, but let's see how that goes. What I'm going to do first, I'm going to take out my phone, because I actually wrote some code before. Given I'm short on time, I'm going to be peeking. Because unlike capture checking, I want to produce something that works. And to do that, actually, I have to consult with the Oracle, which is myself from about 2 weeks ago, I think you told me about it. Right. So I mentioned renovations, and I want to set the scene. Recently, I ordered a horrific amount of blinds. Blinds like these ones, but I ordered pleated blinds. And the company had like a very weird thing where you could order some of the blinds, but like if you choose the wrong fabric, you would not be able to get the blinds of the size that you need in that fabric. So you had to search through fabrics that had like limit on length, limit on width. It was a bit annoying. And then that gave me an idea. That idea was I just went to a different website where that problem didn't exist and literally solved everything within 5 minutes. But I couldn't forget about that particular website. And so I thought, how do they manage their stock? Like, because the stock is weird. Like you have stock of particular size, and then order comes in, they cut it out, and that leaves either a very kind of narrow strip of brawler blinds left. Someone could order that, but that lowers your ability to fulfill orders. So I thought, if we're going to talk about a real problem, let's do a roller blind shop. So to do this, we're going to start with a bare bones template. So I'm going to write everything from scratch. I hope that works. And first, we're going to use the Scala Native G8 template, and we're going to just clone that, default settings, and then let's see what we get, right? So in build SBT, yeah, let's see. In build SBT, Scala version, enable plugin Scala Native, log level info. I don't know why that is there, not necessary. We import some stuff just to make it simpler for us. We're going to modify some of those settings, and I'll explain why in a second. So the first thing that we're going to do source level debugging. Look, Metals worked on the first try. Imagine that. I'm glad this is being recorded. So we're just going to enable source level debugging config enabled, because I want to show you something later if I have the time. And if I don't have the time, I'll just show it somewhere in the middle. And the other thing I'm going to modify is so Scala Native, I'm not going to go into details, but Scala Native used to rely on C++ exceptions, because exceptions are when you work on the JVM, exceptions are given to you by the runtime. They exist. You know, you get a beautiful stack trace. None of that exists when you're working the native code. Like if you've ever worked with C++ or you work with Rust, even the panics, like it says, Rust says, enable backtrace. You have to pass an environment variable so it does do the backtrace, because collecting the backtrace is a very inefficient operation in native binaries because of where the debugging information is stored, and because you have to traverse the stack and you have to invoke some things, and you have to, it's kind of horrible. And there are lots of libraries for C++ that basically provide 3D printing of exceptions because it's just not a thing in the native world. So with the recent changes to Scala Native, they managed to find a way to implement exceptions without relying on C++ runtime. That dramatically increases portability of your Scala Native applications, because you don't need to rely on C++, which has all the bad parts of C and adds a lot of bad parts of its own in terms of header management, platform management, and all of that. But for this, because we're going to be using C++ a little bit, I'm going to explicitly enable this by just adding this to compile options, and the Scala Native tooling will just detect it. So CXX exception. Let's hope that's right. Let's see what we have in main Scala. So not much. It's just regular kind of hello world. And we'll write some Scala code, and then we will gradually do things that I wouldn't recommend you to do blindly, but they are fun to do nonetheless. So we will gradually rip parts of Scala and replace them with C++. So curtains, right? Let's represent curtains. Width is an integer, height is an integer. Someone in the back, which character the cursor is on? Okay, good. You can see that. Width and height. So we're going to manage a stock of that. We're going to manage that very simply. We'll just have an array buffer of curtains, because, you know, it's live coding, don't use mutable data structures. And the first thing that we're going to do is we're going to set the scene. What do we want to achieve? I want to build a web service. That's already going to be a challenge with Scala Native because of things I will tell you about. I want to build a web service that exposes the current stock, preferably in JSON format, and allows you to order curtains, like submit orders. And the only bit of validation is going to be that the current state of the stock is able to fulfill the particular order. And fulfillment is basically the order comes in and it's for width and height. And then do we have a curtain out of which we can cut out that rectangle? That's it. And then as we modify the stock, the remainder will just get smaller. So we'll start with just adding something to our stock. So let's say we have a curtain, so regular 100 centimeters, 240 centimeters height. So HTTP. Unfortunately, currently, majority of the HTTP frameworks that we work with, they sort of boil down to very few Java libraries. So Cask, if anyone worked with it before, it relies on Undertow. Undertow is itself implemented in terms of the standard sort of Java HTTP primitives, which are themselves implemented in a mixture of Java and C++, platform-specific, GPL license. Don't look at that code ever, because you will be sued by Oracle or Google. One of them will basically come after you. I think Oracle. And then all of the other frameworks, like they either use Netty or they rely on the very bare bones JDK HTTP server. So when we think of the plethora of the different HTTP libraries we have, they all boil down and delegate the hard part to very few libraries implemented in Java. We don't really have many native Scala implementations of the entirety of the HTTP stack with the sockets and parsing of the messages, connection management, all that. The only one that I know that is pure is the FS2 networking stack on which HTTP4S is built. And that's why it's the only library that actually cross-compiles Scala Native and pretty much works everywhere. The only thing that you need there is cryptography, because we also sort of, like when you run an HTTP request in Java application, you just do HTTPS and then Java does the rest. But there's a lot of cryptography in there that is written in C or C++ or bouncy castle in Java. Like we take a lot of those things for granted. So the first problem that we kind of see is that we don't actually have a small kind of very bare bones HTTP library that works directly in Scala Native. So as any normal person would do, I'm reaching out to C++. So in C++ and in C world, if like anyone here ever programmed professionally C or C++? Yeah. Oh, well, good. Also, the age group is kind of weird on that one, guys, if I'm being frank. But a lot of libraries are distributed in the weirdest possible format. One of them being single-header libraries, which all the tooling struggles with, but you literally copy a single file into your project and you're done. So in our case, this is the CPP HTTP lib. Seems to be popular, 14,000 stars. It has a single file, http lib.h, which GitHub will struggle to load, and it's how many? Oh, yeah, it's a lot. So all of this single file, 11,000 lines. So what I'm going to do, I'm just going to copy that in my project, but to a particular location. So one of the benefits of Scala Native, one of the things that I find most amazing about it is that you can quite easily integrate compilation of native code directly into your project. In this particular case, you create a magical folder called resources/Scala Native under your src/main. And then what we'll do, we'll just get that file and drop it in src main. Come on. Oh. The main resources. We'll just W get it there. Just W get it down. There we go. Okay, so at this point, all we have is a single HTTP lib file that sits in the Scala Native folder. All the files put there, the compiler will pick it up and will compile it into object files and will add it to your binary. So that's very nice. The problem is, interop with C++ is not a thing languages can do. Rust needs a bidirectional binding generator, which is difficult to manage, but it's possible. Zig just refuses to do it. The only one that attempts to do crazy things with it is Swift, from my understanding, but they have the benefit of owning the whole tool chain. It's LLVM, Clang, and Swift, all sort of boiling in that same delicious applesauce. And so they know how to do it well. And so they're doing crazy things with it. In our world, we cannot do it. So what I'm going to do, I'm going to reach down to a lower level. And the lower level is C. So Scala Native includes a plethora. I'm going to use that word a lot. I've rediscovered it recently. It's fantastic. A plethora of different interop features for C and C++. Well, for C. But I'll explain what I mean in a minute. It's basically, you can write code in C++ that looks exactly like C, is interpreted by the C++ compiler, and then it will be sort of embedded in the binaries in the shape that the C programs will understand it, because there's a thing called mangling, and it's necessary to encode some language features that don't exist on the very low level. On the very low level, there is so little of the things that we rely on and that we like. So the first thing, what I want to do is I want to provide a very thin C-like layer on top of the HTTP abstractions. So you can guess what I'm doing. I'm just doing server error. I will need this just to send HTTP codes back. So bad request, that's 100, I think. And that's going to be code. So that's just an enum. They don't exist at runtime. It's just all going to be numbers. The next thing that I'm going to do is content type, because I want to do JSON, text, and none. So what do you think? Yeah. Then I want to provide a very thin kind of encoding of a request, of a response. So it's going to be a struct, because all we can rely on is structs. There's no classes, no like rich fields, nothing like that. You have enums, you have structs, and you have functions that take very limited number of types. That's the C interop that every language has to contend with. And that's how you talk to like Linux kernel and all that. That's the language of the world, frankly. That's why we have so much C, which is quite upsetting for security researchers. So body type, and then the body is going to be a delicious pointer to nothing. No type, there's no type safety here, just nothing. And we'll use this response. So that's our basics done. And this is very kind of generic for a C layer on top of an HTTP library. What I'm going to add is a struct that represents handlers, represents the operations that we want to override and use Scala Native for. So it's going to be a struct, and then the two operations that we have is list the stock and submit an order. So what I'm going to say, it's going to be a C function pointer. And to look up the syntax for this, I genuinely need to stare at my notes because it's not obvious. If you thought like functions with single arrow are weird looking, this is a function in C. There we go, void. So this takes, how to read this in the least obvious way possible. The thing with the pointer on the inside, list, that's the name of the function. That's the return type. That's thankfully in the obvious position. And this void, that basically means that it takes no parameters. If I delete this, C will just interpret that as a double pointer to a struct called rest. So you need to add this, obviously. I'm going to call this struct handlers. I think it's a good name. And so the next one is going to be create, right? And the parameters that it's going to take are just two integers, width and height, nothing. So this is the sort of, we will write a bit more glue code, but we will implement our stuff in terms of those things. The last thing that we're missing is a function to start the server. Because again, the stuff to start the server from the HTTP lib is C++. We cannot access that directly. Like it's hidden behind a lot of levels of misdirection. Because C++, like Go and like Rust, they want to talk to other Rust things. Like that's where things work. They don't want to talk to C things. They don't want to talk to Scala Native things. So you have to force them to do it. So to start the server, what we need is handlers. In this case, we're taking the struct by the address of it, by reference, not by value, because Scala Native cannot take structs from CWorld by value. That's just a limitation of the interop. It's unclear if or how this will ever be solved, but you have to use pointers. That complicates things somewhat, but it'll be fine. Then we take a regular C string just for the address on which we bind. This could be localhost and port. That's the thing. So that's our entirety of the glue code for the interop. That's the main function, and we need to initialize the handlers with it. So how do you work with it? At the moment, main Scala does sort of nothing. What I want to do, I want to generate some bindings. So I maintain a bindings generator for Scala Native, specifically because I work a lot in that space. And the thing that I want to do is I want to take that glue code that we just wrote, and I want to generate a sort of more idiomatic wrapper on top of this. I don't want to mangle all of this manually. So SN bindgen, that's the beautiful name of the tool. I don't like clever names because people then forget what the thing actually does. This is SN Scala Native, and it generates bindings. That's all it does. And the header is going to be that glue header. So we're not pointing it directly to the C++ library. Resources, Scala Native, HTTP-lib, glue. That's the one. And I want to I wanted to generate the Scala code because for something, the binding generator can generate actually two parts. It can generate Scala code and some corresponding C code to basically marry the things together to work around that limitation that I've just mentioned. Because a lot of the libraries, they do take struct by value. No one would take a struct of two integers, which is a pointer on a map, by reference. No one does that. So the binding generator will generate some wrappers for you just to make that palatable. But in this case, I know that this is not going to happen, so I'm just going to generate the Scala part of the story. So let's do, all right. Made a mistake. But thankfully, the client compiler shows me nothing. Oh, okay, right. Okay, so because we did that extern C thing, we have to tell Clang, which is what binding generator is using, that we are compiling C++ code technically. So we'll just pass this, X C++. There we go. So that's the Scala code generated. I'm going to generate it directly to a file so that we can see the results, Scala, and I'm going to call it httplib.scala. Okay, that's enough terminal for now. Let's take a look. So actually, there is some like private stuff to make enums work a bit better. It picked up the JSON, the text, and the none, defines them. This function doesn't work, even though it's beautiful, because inlining doesn't work the way I thought it does. So ignore that. It defines some extension methods. But as you can see, it's using opaque types and all of that, all of the goodness from Scala 3, just to make sure that we do not box things when we do interop with C code, because there is just no point in interoping with C code where you use classes, allocate on the heap. So this tries to use type aliases as much as possible. And it generated handlers for us. There's a lot of code in here, but the one thing is that you can set, list, and create the operations that we just talked about. And it uses this class called cfuncptr. One is with 0 arity because it takes no parameters, and the create one takes 2 parameters. This looks ugly, but you will never have to see that. And the reason you never have to see that, Scala Native comes with an implicit conversion that allows you to just use Scala functions to implement this. That's exactly what we're going to do at this point. First things first, for JSON, I'm just going to use upickle. And I don't know what the version is actually. 4.10 maybe? Sorry. Because the reason, yeah, I just want to have some JSON in here. So I'm going to do that. Does that work? Smoothly. We'll just do derives read writer. That's the easiest way just to get JSON. And so the next thing I'm going to introduce is zones. So zones allow you to control allocations and create pointers to objects created by Scala code so that you can pass them to C. So to get access to this, yep. Say unsafe because we are entering unsafe memory territory. So the way you're supposed to use zones is you're supposed to do it like this. You're like, oh, zone, and then it gives you a context function, and then you can allocate things here because they're all using zone as an implicit parameter. That's the way to use them for short-lived allocations. Unfortunately, it's much easier to do long-lived allocations for this particular application because C functions cannot capture the local state of Scala code because it doesn't exist. C doesn't have the notion of local scoping and values that live somewhere in the heap and then they're collected. No, it doesn't know about any of this. So we're just using, our stock is global, our zone is global, and we're just going to keep allocating in that. Obviously, that's an obvious memory leak. I'm not going to deal with that today. So the first thing I'm going to do is for the hello program, I'm just going to do given zone equals Z so that all of the code works the way it is. I will do handlers. So you can see it picked up our bindings. I will just allocate that. And let's set the first one. So we'll just do handlers. This syntax is dereferencing a pointer. Oh, yeah, I should import that. Yes, import httplib, because that's the package that we put it in. Okay, so that should work now. Because this actually returns a pointer. Come on, SBT. Did I? HTTP.Scala, yes. SRC main Scala. That should work. When something doesn't work, we just do short sources. Yes, it says httplib. Oh, my apologies. That's just the bad encoding of the imports that I have. httplib.all. So what is handlers? At this point, handlers is a PTR to handlers. So we allocated it, and it's using this zone to allocate it. So the exclamation mark is just dereferencing a pointer. So what in C would be a star. In star, that operator cannot be overloaded. In Scala, that operator cannot be overloaded. So we're using this exclamation mark. I dislike that syntax tremendously, but you know, whatever. So list is a function that takes no parameters. And because of the implicit conversion, we can just basically say, just create a response. You can see you get autocomplete for all the different things. So it's kind of like writing Scala, but this is actually writing it with a bit of interop. So we're going to do OK, and then body type is going to be JSON, and then the body is going to be a C string of the stock that we have. And to do that, you use the toC string function, and then we use the upickle function write and then you just do this. So that's how there's upickle from Scala working there. This is, oh yeah, so you can see closing over local state of lazy value given zone $LZ. Speaking of wonderful error messages, right? Am I right? But it's sort of like that got better. It used to be a lot worse. So the reason is this code is implicitly referring to the zone that it found in scope, but like because the C function pointer, that scope doesn't exist. It's gone. It doesn't just C doesn't know about it. So what we do instead is we redeclare a implicit zone by directly referencing a stable identifier. So in Scala 3, that means it's in top level scope, or it's in an object, or somewhere with a stable location, so that it doesn't use local scoping. So that just works. I'm gonna do create as well with some basics. It takes width int, height int. I'm gonna do this, and then let's write some C++. Woo! So, because we only defined this very little layer of interop, we actually need to write some C++. And I'm going to be heavily consulting my notes on this one, because I've not used this library, and then I forgot everything about it. So the first thing is the trust include. We include the httplib.h, and we include our glue, because we need to sort of define the C++ server code in terms of both our interop features and C++. So let's start with a function, and you'll see how that goes. It didn't give me autocomplete. Okay, there we go. So how does it look in terms of the C++ library? So you first define your server. That will be initialized with the default constructor. And then you just do get, and then you set the root. That's going to be /list. And then you, this is the syntax in C++ to capture all local variables by reference. I actually kind of like that. That's very explicit, but it looks very weird. But C++, because this is C++ 11, C++ is getting much better than it was back in your youth. There are some features that I would like to use from C++ 17, but we cannot currently use them in Scala Native. It's not a limitation. There's already a fix for it. It's just, for example, in here, you could do like const auto request and then move on. But that's a C++ 17 feature. So httplib request, and then we will just have a reference to that. And then const httplib response, that's also pre-allocated for you. And then we define the body of the function, right? Auto is fantastic. And we'll just invoke the operation, because you can see that function is getting handlers. We will provide them from the Scala side, and we'll just invoke it here. And there are some things that we need to do. We need to like prepare the response in the way that the C++ library expects. So I'll just immediately extract that into a function so that we can reuse it on both routes, on the list and the create. So it will basically align the response from this HTTP library and the response from the Scala side. So the status, because it's just a number, it should be like this. I'll name it res and resp, and then you guess which one it is. You know, I'm not here to teach you about practices. I'm here to eventually get to assembly. So we'll just do res status. Oh, this reads wonderfully. Look at this. We'll switch on the body type. If it's JSON, we just need to basically say that in the httplib response, we need to set the content, and then we will do a static cast. So because we know that the data in that pointer, that opaque byte pointer, that data is going to be a string because the body type is JSON. So we'll reinterpret that to be a C string directly, and then we'll use the body from there. And then we'll just set the application/JSON. I'm sure actually httplib must have something for this, but we'll do the same thing for text, though actually I don't think I'm using text in this. We'll just do text/plain. And then for everything else, which is in our case is just none, We'll just not set anything. No headers, no body. We'll just ignore that. So that's all it is. You can see it's modifying a variable that is being passed. That's not something you see in Scala ever, pretty much. So we'll just do prepare. Yeah. One of them. Res and res. Beautiful. Look at that. Oh no, did I? Okay, I named it res. Okay, that's on me. Not matching call. Ich spiele response, and that's a response, yes. Oh, no way. Anyways, you know, whatever. We'll fix that in post. Let's do the create. That's going to be a post. And what we're going to extract, we're going to ship the values of the width and height, not in JSON body, because I don't know how to parse JSON, to be honest. I'm just going to use forms. So we'll just do auto width. It's going to be request get param value, I think. And we'll just do width. And we'll do the same for height. And we'll do create. And we'll invoke it with width and height. Yep. Why are you being so difficult? That's correct. Oh. They're supposed to be both this one, but that's... no, it shouldn't return anything. It should be void. Am I being hoisted by my own naming petard? I will not listen to that. Oh, maybe. Oh, it's the const. The compiler actually was, well, you know, we tend to shit on Scala error messages, but honestly, like the compiler saw the difference between const, and it's like, no matching function call. I have no idea what you want to do. I have all the information, the 20 lines that you've written, but you know, you're on your own. Oh, those are strings, so we'll just cast them with std s2i because you know characters are expensive. Std s2i. There we go. Oh, look at that. And then all we need to do at this point is print out something that we are starting server at, and then we'll do socket. Anyone recognize this std_cout? Like if you went to uni and you did C++, like this, the hello world that requires to do this. Well, I mean, yeah. Port. Okay. And then wonderful. Endl. There we go. And so the only thing that we need is basically say server.listen, and then you do socket and port. There are some implicit conversions in C++ that basically, because this actually takes a string. If you take a look at the definition, it takes a std string, but what we're passing it is a C-style zero terminated string. So, you know, implicit conversions are everywhere. Okay, so that's, well, theoretically, that's all of our C++ code done. So let's maybe write some Scala code. Before that, I'm going to see if this still compiles. So to compile the native code, we actually need to link the binary. So I'm just going to do that using native link. Which one? Hello. Don't have multiple. Oh, okay, yeah, because I didn't remove the old stuff. There we go. So how is our create handler going to look like? So the first thing, I'm going to use the boundary. Mainly, you know, there's no good reason to use that, but I want to traverse the list of current stock. I'm going to zip that with index, and then for each certain index, I'm going to basically say if rectangle fits. I'm going to name this function rectangle fits Scala. Rectangle fits Scala. And I'm going to not use curtain, and you will see why. So I'm going to just basically write it all down by hand, like a caveman. curtain height, and then it's going to be order width and order height. And so the function sort of writes itself. Basically, curtain width has to be more than or equal than order width, and the curtain height has to be more than or equal than. There we go. I'll explicitly annotate that it's Boolean. So if rectangle fits Scala, and then I'm going to do this curtain width, curtain height. This is thrilling, right? Am I right? Aren't you glad that you came? Okay, then if it fits, we're going to do something. I'm going to reformat that real quick. Okay, yeah. So if it fits, what I'm going to do at that particular index, I'm going to basically say here, I'm going to create new curtain, which will have a reduced width. And curtain height. I should have chosen something one-dimensional. There we go. So we're doing this. That should do. But the thing is, we also need to return a response. So our response in this particular case, we're just going to use boundary break, and we're going to return the response directly. So in this case, we don't need to return any response. So it's going to be code.ok, body type none, and then we'll just return null. That's it. And if the rectangle doesn't fit, I want to say, well, actually, no, I want to continue. And the reason I want to continue is because, first of all, let's start the boundary. Is if we manage to get to the end of that block without ever breaking and like finding the curtain that actually fits, we need to return the response that something has gone horribly wrong. So we'll do code bad request, body type text, and we'll say, yeah. This needs to be a C string. And so Scala Native provides you this string interpolator, which will magically allocate the string somewhere in a static area, pass it. So it's going to work wonderfully. And the order doesn't fit. There we go. Fix this. Cool. So what is broken? Again, we're closing over the local value of the state. So again, I will just introduce the zone back into the local scope so that this doesn't escape. And now that we have our handlers, they're fully set, we can just do start server. Handlers, again, C string, localhost, and then 8899. So let's see if any of this works, right? I'm going to do native link. So what native link does is first it takes all the native code that you have. It will compile that into a set of object files with just your flags. Wow, that actually show where the binary is, and I'm going to launch that separately, even though, see, so it shouldn't be rebuilding. So I don't know, it has to be a bug. So I'm going to take that here. I'm going to create a new. Okay. So of course, copying from Vim. So yeah, starting server at localhost 8899. So let's see if this actually works. So I'm going to do curl list. Beautiful. So that's JSON. That's beautiful, beautiful organic JSON. And then if I do create, yep, so that worked. If I do it again, order doesn't fit. So this is C++ code running Scala Native, Scala code through a C-level interop. Now, I know, right? Come on, live, right? Live, and it worked. But I'm not happy with this. And the reason I'm not happy with this is that, you know, I have ambition. You know, I work at my job, I have a kid, it's tough. I don't want this to be just the thing that I show you and you walk away thinking, oh, cool. And then you forget about it for the rest of your life. I want this to feed me and my family for like the next 20 years. So this has to be web scale. And for this to be web scale, obviously, I have to look at my system and see if I get 10 billion requests a second for curtains in my shop. No, that's my dream. No laughing. What will be the bottleneck of this whole thing? And so I talked to my senior engineers, and we decided that the bottleneck is going to be this function doing the Boolean operation. Because we're going to keep just testing orders. All of the HTTP stuff doesn't matter. This pure function that is probably inlined by the compiler, I will rewrite that. And as anyone who's ever been in a company that decides to randomly rewrite something in another language, the choice of the language is often quite stupid. So we're going to go and write this in assembly. How do we do that? First of all, Scala Native tooling automatically picks up C, C++, and the header files for all of those languages. It can also pick up assembly files. And assembly files have the extension .s uppercase. So I'm going to write this function. This caused me so much pain because the way it's written on my ARM64 Linux laptop that runs on Mac hardware, it's slightly different to the ARM64 Mac laptop running on Apple hardware. And so I didn't recognize that for maybe a couple of hours. That caused me great stress. So the first thing, we're telling the assembler, anyone here writing assembly in the daily job? No? But at uni, you must have seen something. I'm gonna make the text bigger because the function is gonna be short, but it's gonna be dense on value. So first we're gonna say, and I think that's what it means. We're gonna open the .text segment of the binary. We're gonna tell the assembler to put this in the .text because obviously code goes into text. So now that we have that out of the way, then we need to say that we're defining something that should be global in the binary, because in the level of binaries and native code and C and everything, you don't have field names, you have offsets in the binaries. You don't have parameters or types, you just have literally labels in the binary where things go. And then those labels get erased by the linker to become numbers, so that you don't even have that unless you're doing dynamic linking. Then names still exist to some extent. So in our case, we're basically saying that during linking, expose the following symbol, the following label as a function called rectangle bids asm. This underscore is required on Apple hardware and Apple assembler. It's not required on Linux. I did not know that. That was a horrible 2 hours. So the way you define it, you see there's no parameters. And how do you know where the parameters go? Because in our particular case, right, what are the parameters? It's just 4 integer numbers. I chose that intentionally because showing you how to read a Scala class off of stack in assembly would have taken probably several hours because I actually don't know how to do it. So I've chosen that format. And what you do is you go to Google and you say ARM64 ABI. And basically what you're looking for is the calling convention. It's at the bottom of this page, and then it's called parameter passing. And what this basically says is that if the argument is this, that, this, and that type, this is what's going to happen to the registers in the CPU when the binary enters that function. So in this particular case, it says that for integers, I mean, I don't know where it says that, but I think this is number 1. It will basically use all of the word-wide registers of the CPU, of which there are quite a few. I'll just keep putting stuff in there. I believe on x86, the convention is a bit more difficult because it puts stuff on the stack, it puts stuff on the registers. It's a bit, on ARM64, it's a bit simpler. It has those registers that start with a W, and we'll just keep populating them. I believe those are actually not the registers because each register in the ARM64 kind of architecture, you can access it as a double word register thing by using like X0, X1, etc. But inside it, it contains a word size register, which you can access by W0, W1. So your assembly code can refer to them, but physically there are much fewer registers. So it's just you're looking at a particular part of it. Okay, so let's move on with the assembly. As I said, the parameters just get passed in the registers, right? So what I'm going to do is in the first register, W0, because that's how the numeration starts, we're going to put the compiler is going to put the curtain width. Because when we invoke that function, the thing is, if we get this wrong, this will not work. We basically have to marry the Scala side and the assembly side, and they have to kiss in the binary way so that this works. There is no checking. No one will check for you that the parameters align because they don't exist. You just have registers. It's a stateful machine. Curtain height, W, thrilling, eh? Again, but it now in assembly, which is order height. So the first 4 registers during that function call, and obviously the function is like, you know, when another function gets called, the registers get overwritten. So they're sort of reset every single time you call a function, more or less. Now, we need to implement that operation that we just had. And so we're going to use the CMP instruction just to compare 2 numbers. And we're going to compare the order width to the curtain width. So V2, V0, and then I'm going to prepare that. We'll do V3, W3, W1 for the height. So compare curtain order width. So W2, W0. And now what do we do? There's no really, you know, not a lot we can do. Returning a value from an assembly function is also not the way you think it is, because we can define a helper function, which will do return 0. And what we do is basically, again, according to the, oh, this is just my blog, you know, how did that get here? The return parameters, I think you start populating some of the registers. In our particular case, I cleverly chose the types to be ints and booleans. And so what we'll just do is, because the Scala Native, it, you know, encodes booleans because they don't exist on the lower level. It encodes it as bytes, I think. So it's maybe 0 byte and 1 byte. So what we're going to do is we're just going to put literal value 0 into the register named x0. And you can see we're using x here because we just want to set all of the bits in that register to 0, not just part of it. So, and this, the hash, which conveniently NeoVim interprets as a comment, that file type hasn't, oh, assembly. That made it worse, but that's fine. It's not like it's helping anyways. There's no navigation. And then there's the ret, which basically, you know, just returns, sort of. So if, in our case, if the order width is higher than the curtain width, then we have to return 0, which is false in our Scala world. And to do that, we use the instruction called, it's basically a conditional jump, break if high. So if, because the CMP, it will set some flags in the CPU saying whether the value was higher or lower. And then be high will basically say, if the left value is higher than the right value, jump to this particular location. So in this case, jump to return to 0. Then we do the same, oh, we already have that. We do for the curtain height. And so if we got to this point after both of the instructions, that means that the order does fit into the curtain. So we do the same thing we did with return 0, just basically say into the register, just put the literal value 1 and do ret. That's it. So as you can see, assembly will not go further down the label because the way this works is like, you just define your entry function and it will execute that, and then you jump to other labels. So we don't need to worry about it falling through to the next case. It's not like a switch statement in C. So that's a rectangle fits in assembly. I am 50% confident this will work. There will be no way to debug this, by the way. So in our case, how do we tell Scala Native that we have this symbol that comes from somewhere called rectangle fits assembly, right? Well, we use the interop functions. We say that it's an extern function, rectangle fits asm, curtain height. We remove the body entirely, and we just say extern. So this will basically, Scala Native will write the interop files in such a way that the linker will try to find a function with this name coming from anywhere, from a dependency you're using, from the Scala code itself, because you can export Scala functions as well. So they could be married this way, from C sources, from C++ sources. It could be a system function, or in our case, an assembly function. So this makes me feel good. Like I spent valuable engineering time rewriting a trivial function in assemblies. This will definitely go viral and, you know, whatever basically gives me money. So I'm going to replace this triumphantly rectangle fits ASM. And let's see if this actually works. By works, I mean, first it needs to link, because that underscore thing, I will never forget it ever in my life. So this should link. Okay, so it links. How can I prove to you that this is running assembly? Well, I'm glad you asked. So the first thing I'm going to do, I'm going to, let's run it, right? That's the first thing that I want to do. Curl. So list, yep, and create order. Okay, so that worked. That didn't. Order doesn't fit. But this was so much faster. No, it wasn't. Like literally exactly the same. But how do I prove to you that this does work? That this actually runs assembly? In a weird way. So what I'm going to do, I'm going to make this slightly, well, I can't make it smaller. I'm going to use the debugger because I'm going to use LLDB. And I'm going to start my process with that. The first thing I'm going to do, I'm going to set a breakpoint. And because we know the name of the function, and we know that that function name wasn't mangled, because it's like mangling allows you to encode some features of the package, the name spacing, the types of the parameters into the single function name. Because on native, there is nothing like that. There's no name spacing, no scoping, just functions, and that's it. So I can do this rectangle fits ASM, because I know that this function name will survive any linking. So I'm going to set a breakpoint there. I'm going to run the process. And then first we're going to do list. That doesn't trigger that function. That's fine. And then I'm going to do create and boom. So you can see, and I'm going to stand up for this. Get ready. This basically says that we are now in the rectangle fits ASM function. And the assembly that I showed you was 6 or 7 instructions, maybe 6. That's exactly what you get. So assembly does not get changed. Basically, you implement it this way, no Scala features, no C features, no compiler for you. Literally, that's what translates. If I just then do next, we can step through it. And at this point, we can do, I think, print W0. Registers. Reg. Reg read W0. There we go. So reg read 00, that's 64 in hex, and that's cool. That's 100. So that's the first register. And if I read W1, you know the drill. So that's 240. And just to confirm, you can see that the connection is still hanging because our process is not responded yet. But that's the request that we sent. There was 100. Oh, that's the stock. That's the length of the curtain that we have in stock. If I read W3, yes. Okay. So if we continue, yeah, that's it. So basically, we got to the return instruction. So we didn't fall through to return 0. That returned. And if we continue one last time, continue. There we go. So that worked. We just resumed the process. And if we just do it again, it will break there again. For comparison, if I were to, and this is the last thing I'm going to show you, if I were to switch back to rectangle fit Scala, native link this baby again. If I get lucky, I will be able to break on a Scala function. It's sort of a hit and miss, to be honest. So let's launch this again. And then I'm going to do set name rectangle fits Scala. That worked. So that's because Scala Native compiler emits debug metadata. So we were able to use just that function name. The actual function name in the binary is this. So you can see it has things you can recognize, right? It has _s. That's what Scala Native compiler emits. It has the main object. It's in the package object. D20. Don't remember what that is, but I think that's returning an integer. 20 is the length of the function name. So that's encoding. If you're interested in how that works, Scala Native org actually has a mangling page. name mangling. So you can see how the Scala stuff gets encoded in just a single identifier, various types, classes, objects, and etc. And if you want to play with it yourself, I have a project called SN Demangler that implements a parser for it on JVM, Scala.js, and Scala Native, just so you can use it in like CLI, etc. So we set a breakpoint there. I'm going to run this. I'm going to list, still nothing. I'm going to create the order. And you can immediately see that there is some stuff in here. I think this is subtracting some stuff from the stack pointer. So obviously, this is already not what you kind of intended. This is encoding some of the Scala features that you have to have because of how the Scala functions get invoked. So that's what Scala Native compiler admits. And you can see the assembly, actually, in this particular case, Scala Native does surprisingly well. The assembly is not, type one letter line, pretty embarrassing. But it still does quite a bit of stuff, right? A lot more than the 6 instructions that we had. So, and that's sort of what I'm trying to show here, is that don't do this. Like this is insane. But the part about using C++ libraries and then building an interop layer the way I did, that is actually quite useful to plug the gaps in the ecosystem, because they're not ecosystem gaps. They are a result of the over-reliance of Scala on the JVM over the years. So other languages like Zig is building their own TLS support, for example, or Rust has a TLS stack already. Scala has relied on the JVM for a long time, and now that languages that compile to native are rising in prominence, we find ourselves with a lot of stuff not implemented in pure Scala. So you cannot move between platforms. You cannot build native binaries. Single-headed C++ libraries sometimes allow you to plug that hole, but it's you could see it's a bit of work. But if the HTTP layer for your application is the smallest part of the application, that is totally doable, because this binary has no dependencies. Like, it's beautifully portable in a way that you don't need to install anything. It doesn't have a runtime. Like, if you just run the command called file on it, look at that. It's a executable binary. And if you do, I think, just to see like what native libraries it depends on. So I'll copy incorrectly again. Yeah. Make this clearer. So all this depends on is the system library, which is what every single binary out there, apart from like the statically linked user libraries, and the C++ runtime, because we explicitly, well, we need C++ because we're using C++. But that's it. That's very portable. You can ship that binary. And if you want to ship that with your beautiful assembly code, Scala Native binary template with everything that you need to ship releases to GitHub as well and upload things. That didn't work. Embarrassing. Let's find one that works, because I changed something blindly. Yeah, there we go. That one worked. So shipping binaries, in a way, they're named the way that PowerCA can resolve them. So you can do CS install, or just install a native binary. All works. Well, you know, some things work. All prepackaged for you. So that's it. What did we learn today? Scala Native, C, C++, and assembly can all live together and kiss in this wonderful binary world. Thank you.
Thank you so much, Anton. Any questions? We probably have time for one. Yeah? Yeah, go ahead.
Question is, when you calling the assembly function, it's not thread safe, is it?
Well, no, it depends on what the function is doing. Because like, if you're calling within a single thread, the stack is safe. Unless you're modifying a variable that is accessed by other threads, that's where non-thread safety happens. But you're not sharing any state. You're passing the parameters by value. If you're passing, like, if you're running this from multiple threads, which presumably, I see, HTTP11 probably runs it like this. Yes, technically, if you don't have synchronization, that function could realistically do some non-thread safe stuff. In our case, all of the values are passed by value. They're copied directly into registers. So there is no, it is technically not thread safe, but you know, it's like not wearing a seatbelt is safe if you're not driving. If you're just sitting here, you know, technically it's not safe, but you're not driving. So in this case, we're not doing any state manipulation, so that's safe. But you're absolutely right.
it's a in a multi-threaded environment, you have to be careful about that, but only for values passed by reference. Or if you're writing to a shared resource, somewhere like to a file, to another socket or whatever, then you can introduce synchronization. And the question is where you introduce synchronization, right? You can introduce the synchronization directly on the C++ HTTP layer. So it's opaque to Scala code, or in the Scala code, just using a log that you store in a global variable. That will work. But yes, you're right.
All right. Thank you again for a very entertaining educational talk. It's really cool what today.
Thank you.
Yeah, so thank you everyone for coming, and see you either next week at the Open Source Hack Night, or I think next month we're on break for talks. So yeah, some other event.